Okay, so let me share my screen. All right, so as I was saying, stoichiometry is that area in chemistry which deals with the quantitative relationships between different substances involved in a chemical reaction. And what you're going to see is that a lot or most of what we learned earlier with respect to naming compounds, balancing equations, molar mass, moles, and all that good stuff will all come into play when it comes to this particular topic. So that's the reason why I covered those topics before we got to this particular topic, right? So, excuse me, just to give a simple example, suppose you're given this equation, the reaction of H2O to form H2 and O2, right? So first thing, of course, we have to make sure is that the equation is balanced, which means that in this case, we're going to need a 2 here and a 2 there, all right? So what do these numbers, the coefficients represent, right? So you have a 2 for the water, the 2 for the hydrogen, and it's understood that there's a 1 here, right? What do those numbers represent? Well, we can look at it at a very microscopic level to say that in this particular case, 2 molecules of water will react to form 2 molecules of hydrogen and 1 molecule of oxygen. So that's one way of looking at it. But another way of looking at it is saying that 2 moles of water will react with produce 2 moles of hydrogen and 1 mole of oxygen, right? So basically, these coefficients in front of the formulas in the balanced equation can represent the mole relationship between the different substances, all right? So if you're given the moles of one substance, let's say, I'm just going to use an arbitrary number here. Let's say it's 1.75 moles of water, right? And you want to find out how many moles of oxygen will be produced. Then we basically can set it up this way. 1.75 moles of H2O, we multiply by a conversion factor, which relates the moles of oxygen to the moles of water. So the way we would set this up here is 1 mole of oxygen above, and down here, 2 moles of H2O. And then all we have to do is do the calculation. Let me do that right now. So 1.75 divided by 2, basically. So according to my calculations, this works out to be 0.875 moles of oxygen will be produced. So that's basically how we can relate the moles of the different substances involved in a chemical reaction and use that relationship to carry out certain calculations like the one that I just did, all right? So it's important that you recognize that these represent the mole relationships and not the mass relationships, right? And that's important because in some questions, you may be given the masses, or you may be given the mass of one substance, and you're asked to determine the mass of another substance. In that instance, the way you deal with that is that, let's say you're given a mass of water, right? What you'd have to do first is convert the mass of water to moles of water, right? And we all know how to do that, right? We divide by the molar mass, okay? And then once you get the moles of water, then you look at the mole relationships between the moles of water and the moles of whatever, oxygen, for example, right? And then you can do that conversion. And then, depending on what the question is asking, if the question is asking for the mass of water produced, then you can convert the moles of water to mass using the molar mass. So basically, most of these exercises that we're going to do in chapter 9 involves those kind of situations where you have to do those kinds of conversions. So with that said, let me clear this here and move on to, oh, by the way, you guys out there in Zoom, let me see if I published assignment 9. I thought I did. No, I didn't. Okay, so let me publish it now so that you guys can access it so that we can all work on these problems together. All right, so you guys out there in Zoom should be able to download assignment 9. So let's start off with the first question. It says using the following equation, and it gives you the, but oh, by the way, before I even go into that, please note that some of the equations in this problem will not be balanced, right? And basically, when it comes to doing these kind of problems, that's the first thing you need to ensure. You need to ensure that you're starting off with a balanced equation. So if the equation is not balanced, you have to balance it before you actually do the rest of the problem. If you don't balance it, then more than likely your final answer will be incorrect because the calculations will be based in part on the fact that your equation is balanced. So in this particular case, the equation is balanced, right? So we don't need to balance it. And the question is asking how many grams of sodium sulfate will be formed if you start off with 200 grams of sodium hydroxide, right? So basically, turn on the pen here. Basically, you're given 200 grams of sodium hydroxide, and the question is how many grams of sodium sulfate you're going to end up with. So as I said before, if you're given a mass of a substance involved in a reaction, in this case sodium hydroxide, the first thing you'd have to do is convert it to moles, right? So you have to multiply by the appropriate conversion factor, which represents the molar mass of sodium hydroxide. And I do know that the molar mass of sodium hydroxide is 40.00 grams, right? You get that by adding up the molar masses of all the elements in the formula. And up here, I'm going to put 1 mole of sodium hydroxide, all right? So that's the first step. You convert from the moles of sodium hydroxide, you're converting from the grams of sodium hydroxide to moles of sodium hydroxide, all right? The next step is to look at the mole ratio between the sodium hydroxide and the sodium sulfate. And based on the balanced equation, it's 1 mole of sodium sulfate produced for every 2 moles of sodium hydroxide reacting, right? So the way we would represent this here, because we want to get rid of the sodium hydroxide mole unit here, I'm going to put 2 moles of sodium hydroxide below and 1 mole of sodium sulfate above. All right? So that this unit will cancel out with that unit. All right? And then the final step is where we convert from moles of sodium sulfate to mass. Now, I don't know what the molar mass is, so I'm going to use the molar mass calculator to figure that out. So for sodium sulfate, the molar mass is 142.04. Make sure you pick up one of those, please. So 142.04 grams of sodium sulfate over 1 mole of the same, all right? And that's basically the setup. So, okay, so that's the setup. So all we have to do now is do the calculation. So 200 divided by 40.00 divided by 2 times 142.04. And when rounded off to 3 sig figs, the answer becomes 355 grams of sodium sulfate. All right, so that's basically it. And please, as I always say, check to make sure that I'm doing the right thing. So make sure you do the calculations along so that, because I could be wrong, I could make a mistake somewhere and I don't want to send you guys astray. So, but that's, I believe, the answer, all right? Okay, any questions about this one? Any questions? Any questions? Any questions out there in Zoom? Okay, so let me, whoops, what did I do then? Clear this, scroll down. Okay, similar type of question, different equation, of course. And in this particular case, the question is asking, and the equation is balanced, by the way, so we don't need to balance it. So in this particular case, the question is asking how many grams of lithium nitrate, so this is what they're asking for, right? Will be needed to make 255 grams of lithium sulfate. So 255 grams of lithium sulfate, all right? So if you understood what we did in the previous question, you should be able to figure out how to approach it. So let me hear what you guys think about doing this one. Let me start you off by writing down the 255 grams of the lithium sulfate. All right? So my first question is, what would you multiply that by? And you guys out there in Zoom, please feel free to make your contributions to this discussion. So, and you can look at the previous problem that we just did to help you. So what would be the first step? Excuse me. Okay, so unfortunately for you guys, you won't have access to this, but you're right. You're going to find the molar mass of lithium sulfate. Li2SO4. And the lithium sulfate molar mass is 109.94. So I'm going to put 109.94 grams of lithium sulfate below, and above I'm going to put 1 mole of lithium sulfate. Okay, so far so good. What's the next step? What's the next conversion factor that you'll be include right here?
1 mole of the drink on the top.
You're going to put 1 mole of lithium nitrate where? At the top? Now, my question to you is, why 1 mole of lithium nitrate? Because remember, if you're looking at the mole relationship, we're going to use these numbers, the coefficients. You see what I'm saying? So I wouldn't put 1 there. I would put 2 here. 4 here for the lithium nitrate, because that's a coefficient before the lithium nitrate. And what would I put down here? 2 moles of lithium sulfate. All right? So that this will cancel out with that. All right? Okay, so one more step, one more conversion factor needed. What's going to be at the top and the bottom of that particular conversion factor?
The molar mass of.
You need the molar mass of what? Exactly. So let me do this again. So LiNO3. Okay, so 68.95 would be the molar mass, 68.95 grams of lithium nitrate would go up top, and 1 mole of lithium nitrate will go below, so that this will cancel out with that, and then we do the number crunching. So let's see what that gives. 255 divided by 109.4 times 4 divided by 2 times 68.95. And according to my calculation, again, please check to make sure I'm doing the right thing. But according to my calculation, I got 321 grams of lithium nitrate. And that's how that is done. All right? Any questions about this one? Any questions? Any questions? Okay, moving along. Clear this first. Scroll down. Okay, now in this case, the equation is not balanced. So we have to take care of that first. Whenever you're doing any problems of these kinds, take care of balancing the equation first before you do anything else, right? So how would we balance this equation? Hold on 1 minute, turn this on. Well, with a 2 where? Okay, I would agree with that. Okay, and that's it. You don't need to do anything else. All right. Okay, so what's the next step? Now that we have the equation balanced, what's the next step? Well, first we have to start off with what we're given, right? 120 grams of sodium carbonate, right? So what do we multiply that by? What goes up top and what goes below in this conversion factor?
1 sodium carbonate.
1 mole of sodium carbonate will go above, and below would be the molar mass. So let me do that molar mass calculator again. So Na2CO3, 105.99 is the molar mass, and that goes here. 105.99 grams of Na2CO3. Okay, so that means that this unit will cancel out that unit. Okay, what would be the next conversion factor? What would be the next conversion factor? Now that we have the moles calculated here, what would be the next conversion factor? What would go above and what would go below? 2 grams? You mean 2 moles, right? You're talking about sodium hydroxide, right? Yes, so 2 moles of sodium hydroxide. Okay, somebody's saying something in the chat. Let me see what this person is saying. Oh, okay. So we're saying this is Bonami Brantley. You corrected yourself. Okay. And your correction is right. 2 moles of sodium hydroxide would be above, and 1 mole of Na2CO3 would be below. Okay, very good. So this will cancel out with this, all right? Next step. Next conversion factor. What would go up top and what would go below?
The molar mass of sodium hydroxide.
Okay, so the molar mass of sodium hydroxide will go up here, right? And we saw from the previous problem that that is 40.00 grams of sodium hydroxide, all right? And below would be 1 mole of sodium hydroxide. So that this will cancel out with that. So again, we have to do the number crunching. 120 divided by 105.99 times 2 times 40. And according to my calculation, 90.5, actually 90.6. 90.6 grams of sodium hydroxide would be the final answer. And that's how that is done. All right? Any questions about this one? Any questions? Any questions? Okay, so basically, let me clear this here. Basically, if you understood all that we have done here, you should be able to do some more. Let me see here. So you should be able to do number 4, number 5, number 6, number 7, number 8, number 9, number 10, number 11. Okay, so up to number 11, based on what we have done so far, you should be able to do, all right? So I'm gonna leave those for you to do on your own. If you have any problems while doing them, please feel free to contact me so I can help you. And the reason why I'm skipping all over those problems, because in the interest of time, I want to get to some other related topics, such as the whole concept of limiting reactants. So let me say something briefly about this. This is something that was discussed in detail in the videos that I've posted. So I'm assuming that you have watched the videos. And if I remember correctly, in the videos, I use the example of somebody manufacturing bicycles, right? And if I remember correctly, the combination of items that is needed to make one bicycle were 2 wheels, a frame, and a pedal assembly, right? So basically 2 wheels plus 1 frame plus 1 pedal assembly would give you 1 bicycle, right? And I don't remember the numbers that I used in the video, but if you're given a certain amount of pedals, a certain amount of wheels, a certain amount of frames, then you can figure out the maximum amount of bicycles you can make from what you're given, from those separate items you're given, right? And what you'll find is that in most cases, one of the items will be completely used up, right? And that item would be the limiting item because that item limits the amount of units that you can produce, right? And then the other items will be left over. We say those items are in excess, right? So that was like a real world example, manufacturing example to illustrate the whole concept of limiting reactant, right? The limiting reactant or the limiting item in that particular example is the item that is completely used up, and the other items that are not used up are said to be in excess. And the key thing you need to remember is that the limiting item is the one that determines how much product you expect to get, right? You cannot get more product than what is predicted or determined by the limiting reactant or the limiting item, all right? So we can apply that same concept in chemistry. In a situation where you have 2 or more reactants and you're given a certain amount of each reactant, you can determine based on the balanced equation. So again, this underscores the importance of having a balanced equation, right? Based on the balanced equation and based on the amount of the reactants, you can determine which reactant will be the limiting reactant, right? And once you determine which reactant is limiting, then you know that that reactant will determine how much product you're going to get. And that's basically what is involved here in question number 12. Because in question number 12, they gave you a balanced equation, and they said in the A part, if you have spilled 6.3 moles of HCl and put 2.8 moles of calcium hydroxide on it, which substance is a limiting reactant? So they're asking you directly to determine which of the 2 reactants is limiting. Once you determine which reactant is limiting, then any other reactant would be the excess reactant, right? So you have the limiting reactant, and then any other reactant or reactants, because you can have more than 2 reactants, would be excess. Okay, so how do we do this? The way we go about doing this is that I would start off with the 6.3 moles of the HCl, and based on that, I would determine how much product I would expect to get. So you can, it doesn't matter which of the 2 products you're going to use. I'm going to use the calcium chloride, all right? So based on the balanced equation, for every 2 moles of HCl, there's 1 mole of calcium chloride. So the way I'd represent this here is that I would put 2 moles of HCl down here and 1 mole of calcium chloride above, right? And then I'd work that out. So 6.3 divided by 2, that gives you 3.2 moles of calcium chloride, all right? And then I'll do the same thing with the calcium hydroxide, 2.8 moles of calcium hydroxide, and I would multiply that by, again, I'm going to find out the moles of calcium chloride based on that. So I would put, in this case, it's a 1-to-1 mole ratio. So I would put 1 mole of calcium chloride above as the numerator and 1 mole of calcium hydroxide below as the denominator. So this will give you 2.8 moles of calcium chloride, CaCl2, all right? Okay, so that's the first step, right? I'll find out how much product you expect to get based on the amounts of each reactant. And then the next step is that I would compare these 2 to see which one is lower. This one is obviously lower, right? And therefore, what that means is that this here, the calcium hydroxide, would be the limiting reactant, right? Because the limiting reactant is the reactant that determines how much product you expect to get. And you cannot get more than the lower amount, right? Of product based on the calculation that we have just done here, all right? So therefore, that answers the A part. The answer is that the calcium hydroxide is the limiting reactant, right? And this is basically what you're going to do in any situation where you're asked to determine the limiting reactant. And not only that, if you're asked also to determine how much product you expect to get, which I think, well, not I think, I know there's some problems later on where that will be asked, all right? Okay, any questions about what I've just done? Any questions? Any questions? Okay, so that's the A part. Now the B part is asking how many moles of the excess reactant remaining. So remember what I just said. Once you determine the limiting reactant, then any other reactant involved would be the excess reactant. So therefore, the hydrochloric acid is the excess reactant. All right? Now, what the question is asking for, let me scroll down here. Right? What the question is asking for is how many moles of the excess reactant remains, right? So what the question is asking for is how many moles of the HCl remains, because the HCl is the excess reactant. Oh, 1 minute. Okay, so what I would do first is try to find out how much of the excess reactant reacted. And the way we do that is that we start with the limiting reactant, which is the 2.8 moles of the calcium hydroxide. And I would find out how much of the excess reactant will react with this much calcium hydroxide. So the ratio between the calcium hydroxide and HCl is 2 moles of HCl above, 1 mole of calcium hydroxide below, and that gives you 5.6 moles of HCl. Now, please note that this is the amount of HCl that reacted, right? What the question is asking for is the amount of HCl that remains, right? So how do we find the amount of HCl remaining? We take the initial amount of HCl and subtract from that the 5.6 moles, which is the amount that reacted. So therefore, moles of HCl remaining would be equal to the initial amount, the original amount, which is 6.3 moles, minus the amount that reacted, which is 5.6 moles, and that would be equal to 0.7 moles of HCl remaining. And that's how you would do that. All right? Any questions about this one? Any questions? Any questions? Any questions out there in Zoom? Okay. Is it okay for me to declare this? All right. Let me do that and scroll down. Okay, here's another one. Similar to what we just did. And in this case, okay, in this case, they gave us a balanced equation again. And the question said that you're mixing 0.048 moles of the aluminum with the 0.03 moles of oxygen. Again, they're asking, what is the limiting reactant? Okay, so based on what we did in the previous example, how would you tackle this problem? What's the first step?
Take the 0.048.
0.048 moles of aluminum. And what would you multiply that by?
either one of the reactants,
I'm sorry?
either one of the reactants, or
I'm sorry, what's that?
is it either one of the reactants we just choose?
Well, if you remember what we did in the previous example, I start off with one of the reactants and I try to find out how much product you expect to get based on that reactant. So how would you do that? What would be the setup here that you would use to do that? What would go up top here as a numerator and what would go down here as a denominator? Okay, somebody's saying something in the chat. Let's see. Okay, so this person said, and it's also Brantley, 2 moles of aluminum over 4 moles of, 2 moles of aluminum oxide over 4 moles of aluminum. And I would agree with that. So 2 moles of Al2O3 over 4 moles of aluminum. All right, so we need to work that out. So that would be 0.048 times 2 divided by 4. So according to my calculation, this works out to be 0.024 moles of aluminum oxide. All right, what next? What next?
Same thing for
the oxygen, right? So 0.030 moles of O2 multiplied by what? What would go up top here and what would go below here?
the 2 moles of
2 moles of Al2O3. And what goes down here?
same thing.
No, not the same thing. 3 moles of O2, exactly. So based on what I see here, this will be equal to 0.020 moles of Al2O3. Okay, so now that we have done those calculations, what will be the next step? You remember what we did at this stage in the previous problem?
Well,
Right, you identify which one is lower, and that would be this one right here, right? Which means that the oxygen would be the limiting reactant. And that's it. All right? Any questions about this one? Any questions? Okay, so that's the A part. And the B part is similar to the B part in the previous problem, because in the B part, they ask for how many moles of the excess reactant remains, right? And remember what we said, once you identify the limiting reactant, any other reactant would be the excess reactant, right? So that means that the aluminum here would be the excess reactant, right? So what would be the next step? Again, feel free to look at what we did for the previous problem.
0.048.
Huh? Repeat that?
When we subtract the
No, not yet. You don't do the subtraction yet. You have to do something first before subtraction. What did we do in the previous problem? Okay, 0.030. Okay, now you sound like you're on the right track. Times what?
4. Times
What goes up top here?
the 2 moles of aluminum.
You sure about that?
4 moles.
What's the mole ratio between the aluminum and oxygen in the equation? What's the mole ratio between the aluminum and the oxygen in the balanced equation given? Oh, somebody's saying something in the chat. Let me see here. Okay, so 3 moles of oxygen. I think you have it. Who said this? Let me see here. Barnamy again. I think you have it the other way around. Or the correct answer is, yeah, you got it. Sorry, yeah, you got it backwards again, right? So yeah, be careful. Be careful with that when you're doing problems. All right, so 4 moles of aluminum above and 3 moles of oxygen below. All right, so this will cancel out with that. So that gives you what? 0.040 moles of aluminum, right? And then what next? Then the subtraction, what you're referring to, would come into play. So what would you subtract from what? So this is the amount of aluminum reacting, by the way, right? So what would you do to get the amount of aluminum remaining?
Subtract that by 0.048.
Yeah, so let me just say moles of aluminum remaining would be equal to 0.048 moles minus 0.040 moles, which will give you 0.008 moles. And that would be the answer. All right? Okay, any questions about this one? Any questions? Alrighty, so let me see here. I'm going to clear this and scroll down to question number 14. Now, in the case of question number 14, the equation, hold on, let me see here. Okay, I'm going to leave question number 14 for you to do. Again, make sure that the equation is balanced. As the question says here, balance the equation first, right? So I'm going to leave question number 14 for you to do. It's very similar to the previous 2 that we just did. Basically, it's the same thing. They're asking pretty much the same 2 questions in the A and B part. So I'm going to leave that for you to do. Let me see what question number 15 says. Okay, now question number 15 is slightly more complicated. So let's focus on that. So in the case of question number 15, they gave you an equation which is not balanced, so we have to do that first. So let's do that first, right? How would you balance this equation? How would you balance this equation? What's that?
2-1-2-1.
2-1-2-1, exactly. 2-1-2-1. Okay. So now that we have that out of the way, the question is asking, it gives you the mass of chlorine and the mass of potassium bromide, right? And the question is asking, which is the limiting reactant? All right, so this is the way we're going to go about it. Now, if you recall, in the previous problems, you're given the moles of each reactant, and we use those to find the moles of product you expect to get, right? In this case, they gave you the grams of each of them. So what you'd have to do in this case is add an additional step in each case where you convert the grams of the substance to moles of that substance, and then you find the moles of products based on that, right? In each case. So in the case of the chlorine, you're going to start off with 0.855 grams of chlorine, and you're going to convert that to moles. So you're going to put 1 mole of Cl2 down here, and the molar mass of chlorine is 70.90 grams, if you do the calculation. All right? So this will cancel out with that. And then the next step is where you look at the mole ratio between the chlorine and one of these 2 products. It doesn't matter which one you choose. I'm going to choose the potassium chloride, right? So based on the mole ratio between the potassium chloride and the chlorine, I'm going to put 2 moles of KCl here, 1 mole of CO2 down here, right? And then I work this out. But before I do that, let me do the same thing with the potassium bromide. So in the case of the potassium bromide, you're going to start off with 3.205 grams of KBr, and then you're going to multiply that by 1 mole of KBr above and below the molar mass. So I have to go to my calculator here. KBr. So that's 119 grams per mole. So I'm going to put 119.00 grams of KBr. KBr. All right. Why did I do that? Okay. So the next step, well, before that, this will cancel out with that. And then the next step, I will look at the mole ratio between the KCl and KBr, right? And it's going to be a 2-to-2 mole ratio. So 2 moles of KCl above as a numerator and 2 moles of KBr below as a denominator. And then we do the calculation, 3.205 divided by 119.00. And that gives you 0.0269 moles of KCl. And then for up here, it's going to be 0.855 divided by 70.90 times 2. And I got 0.0241 moles of KCl. All right? Yes, sir.
Will we not multiply the 3.205 divided by 119 times 2?
I got this here. No, this is 2/2, so that's 1, basically, right? Okay, so what do you think the next step is, based on what we did before? What do you think the next step is?
Find the lowest.
Exactly, which one is lower? This one, right? Which means that the chlorine would be the limiting reactant. And that answers that question. All right? Any questions about this one? Any questions? Any questions? Okay. Let me scroll down. Okay, so the next question is asking how many grams of each product are formed? Now, in order for us to do that, let me clear this. Let me erase this here, create some space here. Okay, now how should I put this? Okay, there are 2 products formed. One of them is potassium chloride, the other one is bromine. Of the 2, the potassium chloride, based on what we have done before, can be easily calculated. It's the easier one to calculate because we have the moles of the potassium chloride that you expect to be formed here. So all we have to do is convert that to grams. So mass of potassium chloride is going to be equal to the moles of potassium chloride multiplied by 1 mole of KCl down here and the molar mass up here. So again, let me go to my trusty molar mass calculator. So KCl. Whoops. KCl. So according to what I have here, that is 74.55. Oops, why did I do that? 74.55 grams of potassium chloride. Okay, so let's see what that gives. So that's 0.0241 times 74.55. So according to my calculation, now this I have to round off to 3 sig figs, which gives you 1.80 grams of KCl. All right. So that's the easy one. Now, the one that's more challenging is well, probably it's not that much challenging, is the bromine. Now, how do we get the mass of the bromine? Well, there are a couple of approaches we can take. We can start off with the mass of the potassium, the moles of the potassium chloride. So let me just say here, mass of bromine would be equal to the moles of potassium chloride, 0.0241 moles of KCl. And then we look at the mole ratio between the bromine and the potassium chloride, which is a 1 to 2 mole ratio. So we're gonna have 1 mole of bromine above, 2 moles of KCl below, so that this goes with that. And then the next conversion factor is basically the molar mass of bromine. So 1 mole of bromine below, and the molar mass of bromine is Br2, calculate 159.81. So 159.81 grams of Br2. And we work that out. So okay, so let's work that out. 0.0241 divided by 2 times 159.81. So I got, rounded off to 3 sig figs, 1.93 grams of Br2. And that's basically how that is done. All right? So these are the two answers for B, this one and this one. All right? Any questions? Any questions? Okay. So that's how that is done. What time is it? 10:20. Okay. All right, so let me clear this. Let's scroll down. Okay, so let's see here. All right, so I'm going to leave question 16 for you to do. You should be able to do that based on what we have covered so far. 17, again, check to make sure that all these equations are balanced before you start any calculations. Let me see here. 18, oh, okay, so let's look at number 18. In fact, hold on, let me check something here. Let me go back to 17, let me see. Okay, so let's talk about 18. Now, 18 deals with another important concept, and that is basically the relationship between what is called the actual yield, the theoretical yield, and the percent yield, all right? So let me deal with the theoretical yield first. So basically, what you'll find is that if you were to perform a reaction where a compound is being made, right? So you know the equation for the reaction, you do the experiment, you get your product, and you isolate it, right? Now, what you'll find very often, and this happens more often than not, is that the amount of product that you expect to get is actually greater than what you actually get, right? And there are several reasons which I went into in the videos that I've created for this topic, right? For example, one of the reasons is that the reaction may be reversible, so that may result in the amount of product you expect to get to be less than what, to be greater, or the amount of product that you get is less than what you expect to get. Another reason would be side reaction. So there are several reasons why that would happen, right? So basically, the amount of product you expect to get based on the type of calculations like we have just done, we call that the theoretical yield, right? The actual yield, as the term suggests, is the amount of product that you get when you actually do the experiment and isolate the product. And the relationship between those two is described by this equation. The percent yield is equal to the actual yield divided by the theoretical yield times 100%. All right? So that's a relationship between the percent yield, the actual yield, and the theoretical yield, right? Now, in the perfect universe, you'd expect the actual yield to be equal to the theoretical yield, right? In which case, the percent yield would be 100%. But of course, we don't live in a perfect world, so more often than not, what you'll find is that the actual yield is less than the theoretical yield, which means that the percent yield would be less than 100%, right? And in terms of actual numbers, in practice, if you do a reaction and you get a percent yield above 80%, you're doing pretty good, because most reactions, the percent yield is actually lower than that, all right? And this is something that you see, it doesn't matter what type of research, as far as chemistry is concerned, routinely, when compounds are being made, they report, among other things, the percent yield of the reaction, all right? Okay, so with that said, let's look at question number 18. It says that it gives you the balance. Well, no, this equation is not balanced actually. So you have to balance it first. So let's do that first. So how would you balance this equation? How would you balance this equation? Excuse me.
It's a 2, 3, 2, 2.
2, 3, 2, 2. Okay, good. Yeah, I would agree with that. Okay, good. So this question says, if the typical yield is this, 86.7%, how much SO2 would be expected if 4,897 grams of zinc sulfide is used? So what we need to do first, based on this equation, they gave us this, right, the percent yield, and they're asking for basically this, right? So we need to find the theoretical yield first, right? And the way we do that is that we start off with the 4,897 grams of the zinc sulfide, excuse me, and we have to convert that to moles. So 1 mole of zinc sulfide will go up top, and then the molar mass, again, let me go to my calculator. ZNS. So 97.46 would go down here. 97.46 grams of zinc sulfide would go down there. And then what do we do next? Let me go back to the assignment. So the next step would be the mole ratio between the SO2 and the zinc sulfide, right? So the next conversion factor would be 2 moles of SO2 and 2 moles of zinc sulfide. All right? And then we find the mass of the sulfur dioxide. Let me just cancel out these units first. So basically, we're going to multiply by the molar mass of sulfur dioxide. So 1 mole of SO2 would go down here. And up top, we're going to calculate the molar mass of SO2. And that is 64.06. So 64.06 grams of SO2. So that's the setup. And we do the number crunching to get the theoretical yield. So that would be 4,897 divided by 97.46 times 1 times 64.06. And according to my calculation, this works out to be equal to 3,219 grams of SO2. So this would be the theoretical yield. All right? So remember now, what the question is asking for is the actual yield. right? So to get the actual yield, that would be equal to the percent yield multiplied by the theoretical yield divided by 100%, right? So the theoretical yield, I'm sorry, the percent yield is 86.78% divided by 100%, multiplied by the theoretical yield, which is 3219 grams, and whatever that gives, that will be the answer. So according to my calculation, this works out to be equal to 2,791 grams. And that would be the answer. All right? Any questions about this? Any questions? Any questions? Okay, let me clear this. And scroll down. Okay. Let me see here. Okay, I'm going to leave number 19 for you to do. Again, make sure that the equation is balanced. Same for number 20. Let me see here. Number 21, too. You should be able to do that. A and B parts. And let me see, number 22. Yeah, you should be able to do number 22 as well. Oh, and that's it. All right. So what I'm going to do now is set up a Dropbox for this assignment. And let me see here. So this is assignment 9. And I'm going to let this be due. Okay, that's a break. I'm going to let it be due on the 25th. So the Wednesday after the break. So let me do this. Okay, and I'm also going to publish the videos for chapter 10. So let me do that now. That's a relatively short chapter. Shouldn't take too much out of you. All right, so make sure you watch those 2 videos in preparation for the next class, all right? And that's pretty much all I have for you today. So enjoy your break as much as you can. And I'll see you Friday after next. All right? Oh, somebody has a question? Oh, yes. Okay. Thank you for reminding me. I'm going to post the PowerPoints for chapter 10 as well. I keep forgetting to do that. Chapter 10, lecture notes, PowerPoint. Okay, thank you, whoever said that, to remind me. Let me see here. Okay, let me post today's video in the module section as well. Okay, For you guys out there in Zoom, I'll hang out here just in case you have any questions until the end of the class time, which is 10:45.
Uh,
What's up?
I was working on resubmitting my assignments that weren't in PDF format before. I think it was assignments 3, 4.
So you have them in PDF format?
Yeah, I just had to submit them.
Okay, well, email it to me because you won't be able to submit it.
Okay,
Yeah.
because I submitted them before late, so would I still get the credit for it?
Yeah.
Okay.
So yeah, email it to me in Canvas, not the Outlook email.
Okay.
All right?
Thank you.
Yeah, no problem.
I made sure the most recent ones were in PDF format though.
Oh, okay, cool.
Thank you.
Yeah, no problem.
Oh, have a good break.
Yeah, you do. Take care.
Professor Nicely.
Yes, ma'am.
So when are we having our next exam?
Oh, I forgot to mention that. I'm going to post an announcement, but since you asked, that exam will be during the week, not the week after the break, but the week following that week. That
Okay.
week, which starts at March. I'm
I
sorry.
think it's April 3rd.
Hold on 1 minute. Let me check and see here. March 30th to April 3rd. Yeah. So in fact, let me just, before I forget, because I tend to forget these things. I'm going to post an announcement about it right now.
Okay, awesome. Thank you.
Number 2 will be during the week of March. What did I say? March 30th. 26.
Have a good day.
Yeah, you too. And I think I might as well tell you guys what chapters that test will be based on. That test will be based on chapters. Okay, if I remember correctly, your first test was based on chapters 1 and 2, was it?
I think 1 and 3. 1 through 3.
Okay, so I'm going to let the test be based on chapters, for test number 2, chapters 4, 5, and 6. So let me put that down. It will be based on chapters 4 through 6, which means that I have to hurry up and grade your assignments and then I'll send them back to you. That will happen over the break. So, okay, so this is, okay, so that's it. Test number 2 during the week of March 30 to the end of that week. And it will be based on chapters 4 through 6. Oh, I see some more comments. Oh, okay. Okay, you guys out there in